Thank you. So I would like to show you a new way to define workflows and execute them persistently with a relatively new member of the ZIO ecosystem called ZIO Flow. First, I will talk about an example to understand what kind of problems this solution is trying to solve. Then I will go into some of the implementation details of it, some properties of the system. And finally, I will talk a few words about the future, what kind of features we think we could build on top of this. So let's start with the example. I don't really have time for a real example. So let's just imagine we have some parameters coming from a user request, let's say. And based on those parameters, we need to execute a series of API calls to external services. And these API calls are such that some of them are depending on each other, some of them are not. So you can call a series of API calls in parallel to another series of other API calls. But while we are doing this, we need to be sure that we support cancellation. If something, let's say, goes wrong in the second series of API calls, we want to stop the whole thing and stop the first sequence as well. And we even possibly have to perform some additional steps to roll back those things that were already performed at the point we need to cancel this flow. And eventually, all these sequences of API calls finish, and then we want to send an email to the user. And we ask something in this email from the user, and we have a way to verify if they performed it already or not. So we enter into a state where we, let's say, daily send an email and then just wait for the thing to happen. And if it didn't happen, then next day we send an email again. And so on until finally the user performed this action. And then we do some last steps to register the completion of this flow. So if we think about ZIO, it already has many features that makes it really easy to define a workflow like this. We can use ZIO services to call our external services. We can use fork, join, or one of the higher level combinators to make things run in parallel. We can interrupt these fibers. We can do things like for each par, which is a higher level operator for concurrency. We can use schedule, delay, and such operators to make things run in the future, basically, wait to implement these periodic checks. But if you think about it, this is not really an implementation of this workflow. It's just a very high-level description. And if we want to actually run this, then first of all, we have to start implementing all these external dependencies. We need something to send the email with. Then we probably want to add logging and monitoring to all these components. Then we have to do something about this cancellation that I mentioned. We need to be able to stop the workflow in any time in a proper way. We need to add things to support the rollback. For that, we have to start recording where we are in the flow, so we know what to revert and what not. There are patterns for this, but it's all additional work to be done. Then we probably want to do retries for our external calls and so on. And at this point, we still don't have any kind of persistence for this workflow. It's running for days, possibly, but what if we have to restart our service? How do we know what kind of flows were running, how to resume them? So this is still not solved, even after adding all these components. But if we try to do the same thing with ZIO Flow, we can write something that is very similar. We are just now defining ZFlow programs and not ZIO programs, but using similar constructs like forking things and using for comprehensions, using for each par, using scheduling and recursion and so on. And once we describe this high-level structure of our workflow, the only thing we have to add is defining our activities, which is ZIO Flow's way to describe how to call the external systems. This is a declarative description of basically HTTP, REST APIs and such, similar to the endpoints API in ZIO HTTP. They will get merged eventually, I think. So that was the example, and let's see some details. As you've seen, ZIO Flow has a DSR, which is very similar to the usual way of how we write ZIO programs. It has all the same operators, like flat map and when and schedule, fork, unit, whatever. So the idea is that you can write a ZFlow program if you know how to write a ZIO program. But it's all persistent. And basically, when you are running these ZFlow programs, every state change gets persisted into a journal table and periodically to a snapshot one. And this state that gets persisted is describing the full remaining part of your program anytime. So it's completely resumable. If you need to restart your service, it's not replaying it from the beginning, like simulating the responses and such things. It's just continuing from where it was last persisted. And we have some backends ready to use. One for DynamoDB, one Cassandra, and one for RocksDB, but it's really easy to add more because it's just a two simple interfaces to be implemented. People sometimes ask about versioning. What happens if you update your workflow definition? What happens with the running flows and so on? So because of how the persistence is implemented in ZIO Flow, each running workflow is completely isolated from each other. Once you submit it, it contains the full workflow definition of what's happening. So it's not like it's pointing to some kind of shared code repository or such things. So they are isolated. There are no compatibility issues. You cannot make a change to the running flows. This, on the other hand, also means that there are no automated ways to upgrade something that is already running. So there is no built-in support for that right now. You have to deal with that by canceling your flows manually or some other way. And finally, how you can control the execution of this? What you can do with all these ZIO Flow programs? First of all, you can use ZIO Flow in two different ways. There is an embeddable executor. Basically, you can use it as a library and put it in your service. But we also have ZIO Flow server, which is an executable, basically a reference implementation of wrapping this embedded executor into an application. It provides a REST API, and in those cases, both with the REST API and with the just with the ZIO interface of the embeddable executor, you got control to, of course, submit workflows for running, then pause, resume, or abort them. You can inspect and modify remote variables that these workflows are working with. So that's one way to, for example, signal changes to them. And that's it. So finally, a few words about the future of ZIO Flow. What's next? We could improve many things, of course. First of all, one important direction is optimizing its storage. The way how currently the state is persisted is not very optimal. It could be improved in several ways. Then, of course, scalability and performance of it can be improved a lot. It's currently running on a single node. It could be made scale horizontally, for example. And finally, there are a lot of opportunities here to improve how we define these activities. Right now, you have to use a DSR, which is similar to the endpoint DSR of ZIO HTTP. But it could be auto-generated from OpenAPI, let's say, or from your ZIO HTTP code, or we can imagine many different ways to improve the developer experience here. Or we could also think about it, and we could make this available for any kind of programming languages without the need to learn this specific functional Scala DSL. And that's something that we are thinking about. So thanks you.